Topic: Circles and Tangents. Learning Area: Geometry.
We know that circle is a collection of all points in a plane which are at a fixed distance from a fixed point. We have studied the various parts of the circle like diameter, radius, chord, tangent, secant, segment, sector, etc. Let us consider a circle and a line PQ. There are three different cases when a circle and a line are given in a plane. Case 1. The line PQ and the circle have no common point. In this case, PQ is called a non-intersecting line with respect to the circle. Case 2. There are two common points A and B that the line PQ and the circle have. In this case, we call the line PQ is called as secant of the line, and the line PQ intersects the circle at the 2 points, namely A and B. Case 3. There is only one point A which is common to the line PQ and the circle. In this case, the line PQ is called a tangent to the circle. At the end of this lesson, the students will be able to prove that the tangent at any point of a circle is perpendicular to the radius through the point of contact. State the number of tangents to a circle passing through a point. Prove that the lengths of tangents drawn from an external point to a circle are equal. Solve problems and prove statements involving tangents to a circle. We know that tangent to a circle is a line that intersects the circle at only one point. Let us perform an activity. Take a paper and draw a circle and the secant AB of the circle. Draw various lines parallel to the secant on both sides of it. You will notice that the length of the chord cut by the lines will gradually decrease. That is, the 2 points of intersection of the line and the circle are coming close and close. In one case, it becomes 0 on both sides of the secant. You can see the position of A1, B1 and A2, B2 of the secant. These are the tangents to the circle parallel to the given secant AB. From this, what we see is the tangent to a circle is a special case of the secant when the two endpoints of its corresponding chord coincide. The common point of the tangent and the circle is called the point of contact. The tangent is set to touch the circle at the common point. Let us look at some of the theorems based on tangents to a circle. The first theorem states that the tangent at any point of a circle is perpendicular to the radius through the point of contact. We are given a circle with a center O and a tangent xy to the circle at a point P. We need to prove that OP is perpendicular to xy. Proof. Take a point Q on xy other than P and join OQ. The point Q must lie outside the circle. If the point Q lies inside the circle, then xy will become a secant and not a tangent to the circle. Therefore, OQ is longer than the radius OP of the circle. That is, OQ is greater than OP. Since this happens, for every point on the line xy except the point P. OP is the shortest of all distances of the point O to the points of x, y. Therefore, OP is perpendicular to xy. Thus, the tangent at any point of a circle is perpendicular to the radius through the point of contact. Let us learn how many tangents can be drawn from a point on a circle by an activity. Draw a circle on a paper. Take a point P inside the circle. Can you draw a tangent to the circle through this point? You will find that all the lines through this point intersect the circle in 2 points. It is not possible to draw any tangent to a circle through a point inside the circle. Now, take a point P on the circle and draw tangents through this point. We can see many lines passing through the point P, but only one line touches the circle at one point. But there is only one tangent to the circle at such a point. Finally, take a point P outside the circle and try to draw tangents to the circle from this point. We can draw exactly 2 tangents only to the circle through this point. What have you observed from this activity? Let us summarize. We find 3 cases. Case 1. There is no tangent to a circle passing through a point lying inside the circle. Case 2. There is one and only tangent to a circle passing through a point lying on the circle. Case 3. There are exactly 2 tangents to a circle through a point lying outside the circle. In the third case, T1 and T2 are the points of contact of the tangents PT1 and PT2 respectively. The length of the segment of the tangent from the external point P and the point of contact with the circle is called the length of the tangent from the point P to the circle. Here, PT1 and PT2 are the lengths of the tangents from P to the circle. The lengths PT1 and PT2 have a common property. Yes, the length of the tangents PT1 and PT2 are equal in measure.